Hey there everyone, welcome to lesson 8 of theme 6 GCSE Geography. We're going to move on to the issue of water now, supply and demand. As world's population is increasing ever more rapidly, we are coming up against an issue whereby there's not enough of things to go around. Water is one of them. So what we're going to do today is identify reasons why some countries use more water than others, and then look a little bit more deeply at the issues associated with water shortages in LICs compared to the issues associated with water shortages in HICs, and then look to see if there's any solutions that could be brought in to readdress the imbalance of water usage and supply around the world. So when you're ready, pause the video here a minute, put this title down, and we'll get started. Okay, so the first thing we're going to investigate is why don't we have enough water? Okay, so if we go back a little bit, right to theme 1, if we look at the water cycle, the amount of water on our planet has been fixed since the Earth formed 4.6 billion years ago. We can't lose any to space, we can't gain any from space. It just goes round in cycles. So part of the problem, though, is that the majority of water on our planet isn't actually usable because it's salt water. So obviously 70% or so of our planet's surface is covered by seas and oceans, and you can't use that. You can't drink it and you can't use it for growing crops. The only water that's really available to us and useful to us as humans is either in rivers and lakes or in glaciers, the melt water from glacial ice, or if you can drill down deep enough to reach groundwater supplies, then you can sink a well or something like that to access the groundwater. So one of the main issues we have is a lot of the water on our planet isn't actually accessible or usable to us. The second issue is, as our lifestyles are improving, our water footprint is getting ever greater. So a water footprint is a measure of the impact on the environment of a product or person. And the way that you work that out is by combining all the water that it takes to create that product or to sustain that person. So just take a moment and in the back of your books, make a list of everything, even just today, so far, that you have done that has needed water. Just a really rough bullet point list. Take a second and do that in the back of your books. Okay, so you've probably all written down things. If you walk yourself through your day, you might have had a shower, you might have flushed the toilet, you might have brushed your teeth, you might have had a drink of water. I don't know, the water in the windscreen wiper washers on your car coming to school, or in your parents' car going to work. I don't know. But we tend to think first off of actual available water that comes out of the tap or out of our shower that we use. But there's another thing that impacts on our water footprint, and it's called embedded water. This is water that is used to grow our food and also make our clothes and other materials. For example, cotton is actually grown, it's a plant. So that plant needed water to grow for us to then harvest the cotton to make our clothes. So water that is embedded, it is within things that we make. Somewhere along the process of making that product, you needed water. It might be in massive volumes, for example, the cooling lakes next to the steelworks in Port Talbot that are used to cool the machinery and cool the steel as it's produced. Or it might be on a slightly smaller scale, maybe several litres per kilo of beef that is made that reaches our plates. Pause the video here a moment, write down the definition of water footprint and embedded water. Okay, so let's try and visualise a little bit more what we mean by embedded water. So, have a little look at this infographic first. It tells you how many litres of water it takes to make certain things. Some of these are more obvious than others. We make paper from trees, and trees need water to grow. So per one sheet of paper, you need 10 litres of water. For bread, the wheat that has been grown to go into that bread, the water that you need to mix the flour and the yeast and all that kind of production process. If we work our way up to some of the higher literage products, 15,500 litres of water to make a single kilo of beef. So all the water that's been used to grow the food that cow ate, to grow the grass that the cow ate, to actual drinking water for the cow, the water used in the cleaning process to produce the meat. It's an incredible amount of water that we use to maintain our consumerist lifestyle, all of these things, these products that we like to use. And that then sort of links into why some countries use more water than others. So on here we've got the old terms, MEDCs and LEDCs. We now use HIC, a high-income country, instead of a more economically developed country. And we use LIC, a low-income country, instead of less economically developed country. And what we've got here is obviously these bars are for more developed countries, and you work your way down to the bars that are for less developed countries. And you've got the meters cubed per person per year that is used in water over here. And when you think of someone in America on average per year uses over 1,500 cubic meters of water, compared to someone in Chad who barely, if that's 50 cubic meters, we're talking barely 10 cubic meters of water for 365 days of life. How are they surviving on that? Chad is a country in Africa. So HICs, why do people in rich countries use so much more water than people in poor countries? It's linked to lifestyle, and it's linked to income, it's linked to money. The more money you have, the more products you buy, and the more access you have to clean water. And what that means is, on the one hand, because of the more products that you buy, you are using a lot more embedded water, and because you have such easy access to water supply, you just turn on a tap or turn on the shower. We tend to be more wasteful of it. We take it for granted because it's at our disposal 24/7. So why do some countries use more water than others? HICs tend to use more water for the couple of reasons I've just touched upon, but a couple of other things as well. In HICs, we tend to have quite intensive farming methods. And what that means is that we farm a lot of stuff on a large area, and to do that, you need plenty of water. And we use irrigation pipes for that. An irrigation system is like a large-scale farm-size sprinkler system, if you like. It's literally pipes that either run along the ground, just under the ground, or sometimes they're suspended on like a framework. And it waters your crops for you. Across acres and acres and acres of land. And that's quite a high-tech solution to making sure that your crops are always watered. So we tend to use that a lot in HICs. Rich countries tend to have industry on a much larger scale as well. So we produce a lot more stuff. We produce a lot more high-end goods. On average, it takes 80 litres of water to make $1 worth of product. In addition to that, we've got lots of facilities, like I said, that use water. So our showers, baths, washing machines, swimming pools, sprinklers on our golf courses, all these things that just aren't a factor really as much in LIC communities. There are instances, though, where LICs may use more water than rich countries. For example, quite a lot of it gets wasted. We'll talk about industry first. So industry tends to be on a smaller scale, smaller factories, smaller scale, less demand for water for embedded products. Lack of access, so people tend to use it more sparingly. Like I said, we tend to take it for granted. A lot gets wasted, so they don't have sophisticated irrigation pipes to pump it like a sprinkler system. Instead, what they tend to do is they'll dig a ditch network throughout their agricultural field and allow rainwater or water from a nearby river to trickle through the ditches and saturate the soil close to the crops in that way. It's a much more basic version of irrigation. But what it means is the water in the ditches, especially if it's a hot country like Chad that we were just looking at, you lose a lot of that water from your agricultural land. It just gets evaporated. So they don't have as, they need more because they're losing more. And the location. So there are LICs. India, for example, is right in the foothills of the Himalayas. They get a lot of snow melt from the glaciers in the Himalayas. They've got major rivers running through India like the Ganges. So sometimes an LIC or an NIC might use more water because it has more water available to it. So what I'd like you to do is pause the video here a minute, put down a main heading, why do some countries use more water than others, and then 2 subheadings and bullet points like I've got here that compare and contrast water usage in rich countries versus water usage in poor countries. If you can summarise it down any further than I've already done so, please feel free. Okay, so the next thing we're going to look at, oh, apologies, I didn't realise there was one more. Pause the video here a minute and add this. Factories of multinational companies use more water. You know, when we looked at Coca-Cola setting up in India, they over-abstract. They take too much water out of groundwater supplies, use it, waste it, millions of litres of water per day to produce whatever product it is they want to produce in that LIC. So, in summary, as a rule, HICs use more water than LICs, and this means that water demand often increases over time because as countries move through the stages of development, the more developed you become, the more industry you have, the more large-scale farming you have, the more consumerism is going on. Consumerism is where people just want more, new, more, and so you buy more things, and that's more embedded water used to produce those products. The exception to this general rule is that sometimes LICs have access to a lot of water. India, for example, like we were just discussing. So even though these LICs still, they use a lot of water, in some cases, they use even more than HICs. You don't have to copy this down. It was just to bring together the notes you made from the previous slide. However, why do some areas of the world have water shortages, even though they may use less water? So we're always hearing about LICs not having enough water, but that graph we looked at earlier says that LICs don't use much water anyway, so it shouldn't matter that you don't have access to plenty of it. Put a subheading, why do some areas of the world have water shortages even though they don't use much? How can you run short if you're hardly using any? You could do this as a spider diagram if you prefer. We're going to make some bullet points or spider diagram notes, and the first one is availability. Most of the water on the planet is salt water. You can't drink it or use it to grow crops. So spider diagram or subheading, why do some areas of the world still have shortages even though they don't use much? First reason, availability. The second reason, if you look at these two maps, this one here shows the relief, the shape of the land. This one here shows precipitation levels on a choropleth map, dark for most through to lightest for least. If you look at the more mountainous areas, more mountainous relief on this map, and compare it with where the most rainfall occurs on this map, what do you notice? There is an exact overlap. It's because of something called relief rainfall. So when moisture-rich air comes in off the sea, so in our case, our winds tend to come from the southwest, and it's picked up lots of moisture from the Atlantic Ocean. When those southwesterly winds arrive at Britain, they are forced, if there's mountains in the way, that moisture-rich air is forced to rise because of the mountainous relief. Rising air will cool, the moisture in it will condense to form clouds, and it will rain. It's called relief rainfall because it is rainfall caused by the shape of the land. Air is forced to rise, condense, and create clouds. So your location, if you are miles and miles away from any mountainous relief, you're not going to get any relief rainfall. Your climate will be drier because you have flat relief. So second bullet point or second element in your spider diagram. Okay, next element. Take a look at these two images. One is a climate graph, and one clearly is showing a very arid climate here. So some areas of the world, your average temperatures are very high throughout the year, and your average precipitation levels are very low throughout the year. So sometimes it can just be the climate type that you live in. If you live in sub-Saharan Africa, you are not going to have enough rainwater readily available for daily use. Versus if you live in tropical Borneo or an area just outside of the rainforest, you're probably going to get plenty of rainfall because you live in a tropical climate. Okay, next thing. We touched on this earlier, over-abstraction. Sometimes water is removed far too quickly. So what happens is, as water soaks into the ground and it percolates down through all the gaps and then becomes groundwater, if you pull all of that water out of the ground more quickly than it's soaking into the ground, That's over abstraction. It doesn't get a chance to be recharged, refilled by rainfall. And that's what's happening with Coca-Cola. They're taking too much groundwater out of the supplies in India, and it doesn't leave any left for villages. Okay. Impacts. Right then, if you have a water shortage in a rich country versus a water shortage in a poor country, what are the varying impacts? So put a subheading, impacts associated with water shortages in LICs versus HICs. And then we're going to deal with LICs first. So subheading or spider diagram. Okay, so these picture clues sort of tell you everything you need to know. If you don't have enough water in a poor country, first bullet point or part of your spider diagram. This is an image of some young girls, probably 5 or 6 years old or younger. Gender roles in LICs, it is their job to walk miles every day to go and try and find some clean water for the family. If you're doing that, it means you're not going to school. You're never going to break the cycle of poverty because you'll never learn to read and write. So number 1, girls used to collect water, not in school, no education, stuck in poverty. Number 2, if there's not enough rain, you're going to get a drought. And drought kills crops and livestock. And that means that farmers have nothing to sell, so they've got no disposable income, their standard of living decreases. And it means people have got nothing to eat. So you get famine, F-A-M-I-N-E. And that pushes up the death rate, puts pressure on the healthcare system, decreases your quality of life. Finally, if there's not enough clean water, you're forced to drink whatever dirty water you can find. So forced to drink contaminated water, diseases like cholera spread easily, higher death rate, lower quality of life. So if there's not enough water to go around in an LIC, it's a matter of life and death. By comparison, let's look at issues associated with water shortages in HICs. So another subheading on spider diagram. Now then, these images clearly are very different to the ones we've just looked at for an LIC. I don't remember when the last hosepipe ban was, whether or not you'd really remember these happening. I remember them growing up as a child, that sometimes we start to run short on water if there's a particularly hot summer. And then there'll be a hosepipe ban across Britain, which means that all non-essential use of water has to stop. So you're not allowed to wash your cars, water your gardens, water your golf courses, fill your paddling pools. You're not allowed to do any of that. Big deal. Nobody dies. It's an inconvenience. So a spider diagram or bullet points, you get a hosepipe ban, can't wash your car, can't water your garden, can't water your golf course. Okay, some golf courses may lose some income. It might affect the local economy a little. Can't fill up your paddling pools. But we don't go thirsty. Some crops may die. Farmers might have a bit of a tough year. But if farmers in Britain have a tough year, the government gives them subsidies, some money to tide them over and things like that. It's not a life or death situation in an HIC if we have a water shortage. So how can we perhaps reduce the issues, solve the issues associated with water shortages? There's 2 different ways you could go about this. You could do something on a large scale, like a water transfer scheme, so moving water from one place to another. For example, building a dam in one country that has plenty of water, and the water that collects in the reservoir behind, you then pipe it somehow to a country that doesn't have enough, that has a water deficit. Or you can work on a much smaller scale. For example, build a little row of stones, like a little mini stone wall, so as surface runoff is happening, it traps that surface runoff and allows it to soak into the soil. Or you put up massive nets, and as fog comes in off the sea, the moisture in the fog condenses onto the nets, and as it drips down, you can collect that water at the bottom. So there are large-scale and small-scale options, and what I'd like you to do, there's a handout that goes with this lesson, 2 handouts in fact. One of them is a PowerPoint that has photos on of a few potential water management schemes. One is a large-scale water transfer scheme in Lesotho. Another is about fog harvesting, and another is about small-scale solutions on individual farms. What I'd like you to do is take a look at those resources that are on another PowerPoint that goes with this lesson, and then either in your books or on the handout provided, either draw out or print out a large table to evaluate each of these projects. Okay? And what I'd like you to do when you're evaluating is expand the points to say why each thing is an advantage of that project or a disadvantage of that project. So for example, the dam meant that lots of families had to move because their land was being flooded when the reservoir filled up behind the dam in Lesotho. So the locals lose their homes, which means they're stressed, therefore their quality of life would be lowered. In addition, they would have lost their farmland and now have no way of making a living, so their standard of living decreases because they've got no cash crops to sell. Okay? So here are some pointers to get you started and to model exactly how I'd like you to fill in the table. So use the photos of the resources on the additional PowerPoint that goes with this lesson. Summarize and add your own understanding to evaluate the projects into the table, please. Okay, we're now going to use our evaluative comments to try, oh no we're not, I thought I'd put in a past paper question. You get away with it. So that's the end of lesson 8. As usual, if you have any questions or queries or you need to email me, drop me a message at gleasona@hopecymru.net. Otherwise I'll see you soon for the final lesson of theme 6, which is lesson 9 on regional inequalities in NICs and HICs. See you soon.